Today we'll discuss Stodola's method. This is to find the natural frequency of a multi-degree of freedom system and also to find the mode shape. So here we see a multi-degree of freedom system problem where x1 and x2, and x3 are the displacements. So it's a 3 degree of freedom system. So how many natural frequencies would be there? There would be 3 natural frequencies. And how many mode shapes? There would be 3 mode shapes. So let's see how to calculate these. So we know that F is equal to, the inertia force is equal to m omega square a. This is from, if you assume x is equal to, that is x is equal to a sin omega t and x dot is equal to omega a cos omega t, x double dot would be equal to minus omega square a sin omega t. So that omega square a is coming from here. So mx double dot would be m omega square a, which is nothing but the inertia force. So F1 would be equal to m1 omega square a1. F2 is equal to m2 omega square a2. F3 is equal to m3 omega square a3. So in this Stodola's method, Stodola is the name of a person who proposed this method. Here we assume the A1, A2 and A3. This is the mode shape. So we assume it to be 1, 1, 1. Remember, in a 2 degree of freedom system we used to find A1, A2. So first mode shape, second mode shape, so we used to find those. So similarly here in a 3 degree of freedom system it is A1, A2, A3. So we assume the first mode shape to be equal to 1, 1, 1. So remember, in the Stodola's method we can only find the fundamental natural frequency and its first mode shape. Okay, we cannot find the second natural frequency or the third natural frequency and the second mode shape or the third mode shape. So what we find from the Stodola's method is only the fundamental natural frequency. What do you mean by fundamental natural frequency? It is the lowest natural frequency. Okay, so the lowest natural frequency is called the fundamental natural frequency of the system. So that is what we are going to find, and its corresponding mode shape, that is A1, A2 and A3, the first mode shape. That is what we are going to find out. But before we find out, we assume it to be 1, 1, 1. Okay, so this Stodola's method is an iterative process. So iterative process, you would have come across many iterative process like Newton-Raphson method or Runge-Kutta method. So even in those cases you assume the initial values and then do the iteration. So similarly here we assume the eigenvector. So these are nothing but mode shapes. So 1, 1, 1 we assume it to be, and then do a iterative process. So I'll explain the process. So in the first iteration, A1 dash, A2 dash, A3 dash should be equal to F1 A11 plus F2 A12 plus F3 A13. F1 A21 plus F2 A22 plus F3 A23, F1 A31 plus F2 A32 plus F3 A33. So how is this? So F is in Newton into A is what? A is the flexibility influence coefficient, so it is meter per Newton. So meter per Newton, Newton would get cancelled, it would be in meters. So this is nothing but the amplitude. So A1 dash means, so this is for the first iteration. Okay, so we have assumed it to be 111 and we check with the first iteration whether it is equal to 111. Okay, so that is the first iteration. So this is what the formula would be. This is same as the Rayleigh's method where you did this W1 A11. So it is very similar to that. So in the first row what you see is all the deflection is measured at 1. Okay, and load is applied at 1 here, load is applied at 2 here, load is applied at 3 here. So there are 3 points. So and here in the second row all the displacements are measured at 2. In the third row all the displacements are measured at 3 for A3 dash. So A1 dash, A2 dash, A3 dash. So this is what the formula is. Now if A1, A2, A3 is equal to A1 dash, A2 dash and A3 dash, stop iterating. So you can stop your iteration if this condition is satisfied. So you would remember the Newton-Raphson method. If the previous iteration method and the previous iteration and the current iteration, the numbers are the same, then you stop iterating. So it is the same principle. So now we'll calculate this. So what is F1? So we'll have to calculate this A1 dash now. Okay, so A1 dash would be equal to F1 is m1 omega square x1 m1 omega square a1. So it is m1 is 2m into omega square. A1 is, we have assumed it to be 1 into a11. What is a11? A11 is 1 by k1. So 1 by k1 is 1 by 2k. So because 2k is equal to k1, so it is 1 by 2k. Okay, so f2 a12. What is f2? F2 is again 2m omega square into 1 into, what is a12? A12 is nothing but 1 by 2k plus f3. F3 is m, because this is third mass is only m here, m omega square into a3, so that is 1 into f3 a13. A13 is what? Again 1 by 2k. Okay, so if you calculate this, a1 dash would be equal to a1 dash would be equal to 5m omega square by 2k. Just calculate this and see. You should be getting this. A1 dash is equal to 5m omega square by 2k. Similarly, we will find what is A2 dash. So A2 dash is equal to F1 A21 plus F2 A22 plus F3 A23. Okay, so A2 dash would be equal to, so if you do this calculation where similarly whatever we did for the A1 dash, if you do this you will get m omega square by k plus 6m omega square by 2k plus 3m omega square by 2k, which is equal to 11m omega square by 2k. So just try it out, you should be getting these. Next, a3 dash is equal to, here everywhere it is into 1 because a1, a2 and a3 we have assumed to be equal to 1. So that is to be multiplied into 1. So since it is 1, I have not put that. So a3 dash is equal to m omega square by k plus, this would be f1 a31 f1 a31 plus f2 a32 plus f3 a33. Okay, so this is m omega square by k plus 6m omega square by 2k plus 5m omega square by 2k is equal to 13m omega square by 2k. So this would be equal to, so a1 dash, a2 dash, a3 dash is equal to, if you take m omega square by 2k as common, it is 5, 11 and 13. So this can be written as a1 dash, a2 dash, a3 dash is equal to, take out the 5 to be common. Okay, so the first number you should take out, 5m omega square divided by 2k. This is done to get 1 in the top, 1, 2.2, 2.6. So this is very similar to in a 2 degree of freedom system when we were doing the mode shapes. Suppose if we put a1 equal to 1, then what will be a2? So this we were finding out in a 2 degree of freedom system. Similarly, if we put a1 equal to 1, then what is a2 and a3? So similarly, this is what we get, and this is not equal to 111. Okay, so this is 1, 2.2 and 2.6, which is not equal to 111, which we assumed initially. So what we need to do, we need to go for a second iteration. So first iteration is done, and this 1, 2.2 and 2.6 is not equal to 111, which we assumed. So we need to go for the second iteration. Okay, in the second iteration, what we do, we assume a1 dash, a2 dash and a3 dash to be equal to this 1, 2.2 and 2.6. Okay, so for the second iteration, it will be a1 double dash. A1 double dash is equal to f1 dash a11 plus f2 dash a12 plus f3 dash a13. Okay, so what will be this? F1 dash means what? m1 omega square into this would be a1 dash, okay, into a11 plus m2 omega square, this would be a2 dash into a12 plus m3 omega square into a3 dash into a13. So if we substitute this would be m1 is 2m omega square into a1 dash is 1 into a11 is, so a11 is 1 by 2k plus m2 is again 2m omega square. Now a2 dash is what? 2.2 into a12 is 1 by 2k. Don't get confused with this decimal and this multiplication. Plus m3 is m omega square. a3 dash is 2.6 multiplied by a13 is again 1 by 2k. So this a1 double dash you should be getting this as 9m omega square by 2k. Similarly, you need to find a2 double dash and a3 double dash. I'll just give you the values. a2 double dash is equal to 23m omega square by 2k. a3 double dash is 28.2 m omega square by 2k. So it is nothing but a1 double dash, a2 double dash, a3 double dash is equal to, if you take this as common, 9m omega square by 2k, you would be getting this 1, 2.55 and 3.13. okay, so previous numbers was 1, 2.2 and 2.6, so it is 1, 2.55 and 3.13. so this is again different, so we need to go for the further iterations. So what I want you to do is, I want you to continue the iteration process till you arrive at a closer value of this, where the previous amplitudes and this matches. okay, so till then you just continue and send me the sheets so that we can later find out what is the natural frequency. In the next video I'll tell you how to find the natural frequency from this, but continue the iteration process and send me the feedback if you are able to understand how to continue the iteration, and then we'll see how to find the natural frequency from this. Thank you.